Hi everyone, this is Mr. Lim again. Today we're going to talk about quadratic functions. For your information, quadratic equation looks like this. Okay, this is the general form of quadratic equation where a, b, and c are constants. And this general quadratic equation can be written in completing square form. This is the completing square form. We will talk about why we want to write the general quadratic equation into completing square form later. And now we'll focus on how to convert the general form into the completing square form. All right. There are various methods to convert the general quadratic equation into completing square form. This is one of the method, very long, but luckily there's shortcut. So please remember this equation because if you can remember this, it will help you to convert this general quadratic form into the completing square form faster. Okay, what we need to do is to identify what is the A, the B, and the C. Okay, so the A is equal to 2, B is equal to 11, and C is equal to 5. Now we can actually put all these values into this equation and to find the completing square form. All right. So my A is equal to 2 and my B is equal to 11. 2 times 2 plus C is 5 minus B squared over 4 times A. So I got 2x plus 11 over 8 squared plus 5 minus 121 over 8. So I get my completing squared form. This is equal to, let me calculate this. 5 minus 11 squared over 8. I got negative A1 over 8. So this is my completing square form. And we can compare this answer with the previous one. As we can see, if you want to use this method, very long method, you get the same answer as we use shortcut. All right, so they are the same. So make sure you know how to write this general form into completing square form. It is very important. Okay, so now why do we need to write the general form into completing square form? Because the completing square form tell us the stationary points of the quadratic equation. All right, for a quadratic equation, it is either in U shape or N shape. So for a U-shaped quadratic equation, it has a minimum point, sorry. And for an N-shaped quadratic equation, it has maximum point. So by looking at the quadratic equation, the general form, we cannot identify whether it is where is the stationary point, where is the maximum point or the minimum point. But in completing square form, we can identify the max or the min point. So first of all, how to determine the stationary point? You must look at the leading coefficient. If the leading coefficient is positive, in this case, the leading coefficient is 2, which is positive, then the shape is U shape, a happy shape. All right. So a happy shape consists of a minimum point. All right. And the coordinate of this minimum point is negative 118, 11 over 8, and negative 81 over 8. So when the time you copy the number here, you have to change the sign. So the x coordinate, if this is a negative value, when the time is copied into the coordinate, the x coordinate, you must change the sign. Whereas the y coordinate, you no need to change the sign. So this is the location of the minimum point. Okay, so let's try a few questions here. So maybe we can just try one question. Say I want to try question B. Write this equation into completing square form. All right. So question B, I have y equal to x squared minus 6x minus 20. Right. So my A is equal to 1, right? My A is equal to 1. And then, so I have 1. My B is equal to -6. So plus -6 over 2 times 2, right? No, sorry, 2 times 1 because my A is equal to 1, right? 2 times 1 squared plus C minus B squared over 4 times A, which is 1. So I get -3 squared, and this one I got -20 minus 36 divided by 4, I got 9. So the completing square form look like this, minus 29. So once again, the leading coefficient is 1. So I have a happy face. So happy face has a minimum point, and the stationary point located at 3 and -29. So if I want to sketch this function, it's very easy because I have already got the stationary point. So how to sketch this? This is located at 3, x is equal to 3, and y is located at -29. Okay, and then the y-intercept is -20. So y-intercept is -20. So say -20 is here. So the graph look like this. It passes through here, and then yeah, this is the minimum point. Okay, so the graph look a little bit ugly. You can correct it. You can make it better. Okay, so here we have a few more questions. So please complete them yourself. Okay, and you can check the answer with your friends later. All right. So yeah, we have additional exercise here. So maybe you can try to write this in this form. Okay, so this is another form of completing square form. Question A. So we have A is equal to 4, B is equal to 9, and C is equal to -2. Negative 2, sorry. -2. Okay, so we want to put this general form into completing square form. So we have 4 bracket x plus b over 4 times 2, which is 8 squared, minus c minus b squared over 4 times 4, which is 16. So this is 4x plus 9 over 8 squared. So I have -2 minus 81 over 16. So 4x plus 9 over 8 squared minus how much do I get for this? -2 minus 81 over 16. So I get -113 over 16. Okay, but this is not in this form, right? Because I don't want to have any coefficient here, but I have a 4 here. So how do I get rid of this 4? So I can actually write 4 as 2 squared, right? So x plus 9 over 8 squared minus 113 over 16. Okay, and for your information, a squared b squared equals ab squared. So I can actually write this as 2 bracket x plus 9 over 8 square minus 113 over 16, right? Okay, so I can apply rainbow multiplication. So finally, I'll get 2x plus 9 over 4 squared minus 113 over 16. So this is my answer for A. So please try question B yourself, and you can check the answer with your friends when you return to campus. All right. Thank you very much. And again, if you have any question, please do not hesitate to talk to your mathematics teacher. Thank you very much. Bye-bye.